Ryan, we begin with a squeegee blade that looks very similar to old-fashioned blades, 3/8 by 2" by the proper length. That's where the game really changes. What we've done is realizing that screen printing is like a trampoline. It's more elastic in the center than at the edges. We've created a hinge that interprets that difference in the screen or in the trampoline. The hinge is higher at the ends and closer at the center. The position and the depth of the hinge and all the details about the hinge are based on your maximum screen tension, your minimum off contact, and the distance between the blade and the edge of the frame. Everyone that you know, all of your customers, will tell you as the image gets bigger, it gets more difficult to print. They're printing with a single axis blade. That's the problem. All blades going through the stroke direction will lift slightly or buckle slightly at the end, straighten out toward the middle, and then buckle as they get to the end of the stroke again. None of them are sensitive over the length of the blade except for Smiling Jack, Dr. J, and Manny. We designed the blade to give you an 8-to-1 ratio, so the ends of the blade deflect 8 times as much as the center. What that allows us to do is provide a standard blade that will fit a variety of customers and applications. Someone has a higher tension screen, someone has a better calibrated press. So within an 8-to-1 ratio, which covers the whole gamut, we can give them excellent quality white prints and color prints and overprints with one blade, one design. We've done something else with the blade. This blade is a minimum maximum blade, which means the hinge side is square. The back side behind the hinge has a bevel on it, and this is our stock bevel. What that allows us to do is use the beveled side for screen mesh between 63 and 156. It allows us to use the square side for screen mesh between 156 and 330. So one blade will give us the best halftones, the best simulated process, and the highest opacity. Our blades are designed so that they can run virtually straight up and down. Now there's a little bit of a secret. We actually build a little bit of bend into the blade. That's what the hinge is about. Because we have the hinge in there, we can run minimal pressure. The load is at midnight. The edge of the blade is at 6 o'clock. So it's very efficient. As I showed you before, if we put any angle on the blade, then the pressure is at midnight, the edge is somewhere else. The blade buckles, we lose opacity, and we cause blurring with overprint colors. Yesterday while we were out, we had several people pick the blade up and they said, "What durometer is it?" And we said, "What durometer do you think it is?" And they squeezed it and they said, "Well, this is 70, maybe 75. The truth of the matter is this blade is an Shore A85. That's what makes it last so much longer than any competitive product. But if you take a closer look, it is easier to compress the hinge than it is to stretch the hinge. Much easier. So this side is more rigid than this side. That's how we get two distinct deposits out of one blade. That's why we differentiate and say this side for 165 to 330, this side from 63 to 156. It's really easy to make a low-cost blade. That's not a problem at all. All the blades in the screen printing industry are polyurethane. There are a variety of types of polyurethane. For Smiling Jack, Dr. J, and Manny, we go to the top shelf product. This is an ester-based MDI, methylene diisocyanate blade. That's what makes it last so long. It's solvent resistant and it's abrasion resistant beyond anything that's off the shelf. We actually test 3 different properties. How does the blade deflect? How does the blade perform under the continued load of the squeegee? And how does the blade spring back to recover its body? Those are the parts that certainly I can't, and I don't think anyone can take and feel and say, yeah, this blade is good or bad. Those are the unseen qualities. Because we've taken the hinge and allowed you to use less pressure and less angle, and there's no buckling, just on that factor alone, a buckled blade will last half as long as a blade that's not buckled. So we've taken into consideration the polymer, the shape of the hinge, the bevel, and the square edge, and their location to give a blade that performs faster with less distortion, better mat down, better penetration, and outlast every blade on the market.